Dimensional geometry problems which are asked in previous years JEE mains papers. So, I will be concentrating more on lines because you get confused when you are doing the problems in lines. So, let us proceed with the problems, and you as already know that the intersection of two planes is a line, and we have the line form in symmetrical form and general form. Symmetrical form helps us to write or solve the problems easily. So, let us try to solve these problems. If the line x minus 1 by 2 equal to y plus 1 by 3 equal to z minus 2 by 4. If this line meets the plane x plus 2y plus 3z equal to 5. You are given that this line meets the plane x plus 2y plus 3z equal to 15 at a point P, then you have to find the distance of P from the origin. This line is meeting the plane. If you are given the line in the symmetrical form, it is easy for you to write any point on the line. So, if we take equal to r, we can write any point on the plane. Let it be P, which is equal to 2r plus 1, 3r minus 1, 4r plus 2. You are given that this line meets the plane x plus 2y plus 3z equal to 15. So, substituting this in this, you have x plus 2 into 3r minus 1 plus 3 into 4r plus 2 equal to 15. So, 2r plus 6r, 8r plus 12r, it is 20r plus 1 minus 2 minus 1 plus 6, it is plus 5 equal to 15, or 20r equal to 10, r equal to 1 by 2. So, you get the point P now, substituting the value of r. 2 into half is 1 plus 1, 2. 3 by 2 minus 1, it is 1 by 2. 4 by 2, 2 plus 2, 4. Now, you can find out the distance. You are asked to find out the distance of P from the origin. Origin is 0, 0, 0. So, distance will be root of x square plus y square plus z square. 16 plus 4, 20 plus 1 by 4, which is 81 by 4 equal to 9 by 2. So, here you should get the idea that you are writing a point on the line and that point is on the plane. So, substitute in the plane, and after getting the point you are finding the distance of P from the origin. The second problem is two vertices B and C of a triangle ABC. If you are given ABC a triangle, these B and C points are lying on the line x plus 2 by 3 equal to y minus 1 by 0 equal to z by 4. B and C points are lying on this line such that BC equal to 5 units. Then area of the triangle, you have to find out the area of the triangle given that point A is 1 minus 1, 2. So, now again we can write any point on this line. Let it be B equal to, if I equate this to R, I will get the point B as 3r minus 2, 0r, so it is only 1, 4r, there the point is 0. Now, let us take one more point on the line, equating this to S. So, you get the same coordinates with r replaced by S, 3s minus 2, 1, 4s. You are given that the distance BC is 5 units. So, when we find out the distance using the distance formula, 3s minus 3r minus 2 plus 2 gets cancelled, whole square, 1 minus 1 it's 0, plus again this is 4s minus 4r whole square. This is given to be 5. So, 3 is, if we take outside, it is 9 s minus r whole square plus 16 s minus r whole square equal to, I am removing the square root, it is 25. 16 plus 9, 25, s minus r whole square equal to 25. So, from this we get s minus r whole square equal to 1, or I can write s equal to r plus 1. So, if I take r equal to 0, s will be equal to 1. So, the points will be, B point will be 3r plus 2, so it is 0 minus 2, r is 0, so it is 1, 4r, so it is 0. C point is again, r is 0, s is 1, substituting this 3 into 1, 3 minus 2, 1, 0 plus 1, 4s, 4 minus 0, 1, 1, 4, and A point is 1 minus 1, 2. In 3-dimensional geometry, area of triangle ABC is given by half AB cross AC. In 2 dimension, we have the formula half into x1, y2 minus y3 everything. So, you will get confused here. Remember, in 3 dimension, when it is area of triangle ABC, it is half AB cross AC. So, here you will find out AB. A is 1 minus 1, 2. So, AB is B minus A minus 3, 1 plus 1, 2, 0 minus 2, it is minus 2. Again AC, 1 minus 1, 0, 1 plus 1, 2, 4 minus 2, 2. If we find out the determinant of this, this is 4 plus 4, 8i. J is minus 6 here, with J we have a minus. So, this is plus 6j, k is minus 6k, and we have a half here. So, this is 4i plus 3j minus 3k, and we want the modulus, we are required to find the area. So, area will be root of 16 plus 9 plus 9, which is root 34. So, area of the triangle is given by root 34. Let us go to the next problem. If the line x minus 3 by 2 equal to y plus 2 by minus 1 equal to z plus 4 by 3. If this line lies in the plane px plus qy minus z equal to 9, then you have to find out p square plus q square. It is given that the line lies in the plane. For this we have a condition. If LMN are the DCs of the line, DRs of the line, then the condition is AL plus BM plus CN equal to 0, and the point x1, y1, z1 should lie on the plane. So, we have to use these two conditions to find out the value of p square plus q square. So, here a point is 3 minus 2 minus 4. From where did I get this? This is x minus 3, y plus 2, z plus 4. So, a point is 3 minus 2 minus 4, and the plane equation is this. So, now using the condition LMN are 2 minus 1, 3. So, we have from this condition AL plus BM plus CN 0, we have 2p minus q minus 3 equal to 0. Cn, p into this 2 plus q into minus 1 into 3. So, 2p minus q equal to 3 is one equation. Second condition, you have to substitute this point in the plane equation. So, 3p minus 2q plus 4 equal to 9, or you get this as 3p minus 2q equal to 5. We have to solve these two equations to get p and q. If I multiply the first equation with 2, 4p minus 2q is 6. Then now subtract this equation. So, you have p P equal to 1. If P is 1, substituting in this, 2 minus Q is 3 or Q is minus 1. So, what will the value of P square plus Q square will be? 1 square plus 1 square, which is 2. So, only thing here you should remember this condition when a line lies in the plane. The distance of the point from the plane measured along the line. You are given a plane, you have to find out the distance of a point P from the plane which is measured along the line. You are given one more line which is x equal to y equal to z. The point P is 1 minus 5, 9. So, now let us write the equation of this line. Because this is parallel to this, we know the drs. X equal to y equal to z is nothing but the line x minus 0 by 1, y minus 0 by 1, z minus 0 by 1. This is this line. Now, we want the equation of the line, say this is PQ. P point is 1 minus 5, 9. So, equation of PQ will be x minus 1 by the drs 1, y plus 5 by 1 equal to z minus 9 by 1. Now, this line, if you write any point on this line, let it be Q. So, any point Q, we can write it as r plus 1, r minus 5, r plus 9. This point lies on the plane. We want the distance from P to Q which is lying on the plane. So, substitute this in the plane equation which is x minus y plus z equal to 5. So, substituting in this, x is r plus 1, y with a minus sign. So, minus r plus 5 plus z plus r plus 9 equal to 5. So, r equal to 14, 15. So, 5 minus 15 is minus 10. So, the point Q will be minus 10 plus 1 minus 9, minus 10 minus 5 minus 15, minus 10 plus 9 minus 1. Now, you are required to find the distance from P to Q. Use your distance formula. Minus 9 minus 1, it is minus 10 whole square which is 100. Minus 15 plus 5, it is again minus 10 whole square 100 plus minus 1 minus 9 minus 10 whole square 100. This is square root of 300 or 100 into 3 which is 10 root 3. So, the distance of the point from the plane which is measured along this line, because it is parallel, we have taken those drs. So, this is how we find out the distance of the point Q which is lying on the plane such that the line PQ is along the other line x equal to y equal to z. Here the point P is the point of intersection of the straight line joining the points Q 2, 3, 5 and R point is 1 minus 1 minus 4. 1 minus 1, 4. With the plane 5x minus 4y minus z equal to 4. 5x minus 4y minus z equal to 1. So, here the point P, you are having a plane, you are given 2 points Q and R. Q and R are intersecting this plane 5x plus 4, 5x minus 4y minus z equal to 1 at some point. Then if S is the foot of the perpendicular drawn from the point T, T is some other point 2, 1, 4, you are drawing a perpendicular to this line PQ. Then length of the segment PS. This is QR, P is a point on the plane, you have to find out the length PS. So, if you draw the figure, then you will get an idea. In many coordinate geometry problems, it is best if you try to figure out what is given in the problem. So, now first thing is you require the line QR now to write any point P. So, QR passing through 2 points and writing the equation of the line passing through 2 points using the formula x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. This is the equation of the line QR. Now, we want to find out any point on this, which is minus r plus 2, minus 4r plus 3, minus r plus 5. This is the point P. Now, the next step is this P lies on the plane. It is the point of intersection of the line with the plane. So, substitute in the plane equation 5x minus 4y minus z equal to 1. 5 into this minus 5r plus 10 plus 16r minus 12 minus z. So, this becomes plus r minus 5 equal to 1. I am substituting this point in this plane equation. Now, simplifying this 17 minus 5 12r, 10 minus 12 minus 2 minus 5 minus 7. So, this becomes 8, r equal to 8 by 12, which is 2 by 3. So, now a P point will be substituting this minus 2 plus 6. So, P will be, P is 4 by 3, then minus 8 plus 9, 1 by 3, minus 2 plus 15, so it is 13 by 3. This is the point P. Now, the second part of the question is, if S is the foot of the perpendicular from T. So, you need not find out the foot of the perpendicular here. Let us write again any point on this line, and because this is the line perpendicular to this, we use the condition for 2 perpendicular lines when we know the drs. So, S point again will be same as P, write it with S. So, it is minus S plus 2, minus 4S plus 3 and minus S plus 5. T point is 2, 1, 4. So, what are the drs of ST? x2 minus x1, y2 minus y1, z2 minus z1. So, this becomes S, 1 minus 3 minus 2, 4 minus 5, it is minus 1. These are the drs of ST. Why did I take drs of ST? Because this is foot of the perpendicular, this is a perpendicular line to this line. So, I know the drs of this QR, which are minus 1, 4, minus 1. So, these two should be perpendicular. So, using the condition A1 A2 plus B1 B2 plus C1 C2 is 0, S into minus 1 minus S minus 4 into 4S minus 2 minus 1 into S minus 1 equal to 0. Minus 16 minus 17 minus 18S, 8 plus 1 9. So, S equal to 1 by 2. So, now I will get my S point. If I substitute 1 by 2, here this is 3 by 2 minus 2 plus 3, which is 1, minus S minus 1 plus 10, 9 by 2. This is my S point. Now, the problem is the length of the segment PS. This is the point S. Where did we find the point P? This is the point P. We have to find out the distance between these 2 points. Again, use your distance formula here to find out the distance. The only thing, when you draw the figure, you can get a clear idea of how we solve the problem in steps. if the image of the point P in the plane measured parallel to the line is Q, then PQ is. The plane is 2x plus 3y minus 4z equal to 22. We want the image of the point P, which is 1 minus 2, 3. In the plane 2x plus 3y minus 4z plus 22 equal to 0. Measured parallel to the line, you are having one more line here, x by 1 equal to y by 4 equal to z by 5. This is the line. So, if we want the image of this point, it will be somewhere here. Now, this is the plane equation 2x plus 3y minus 4z plus 22. You want to find out the image distance, PQ distance. So, let me find any point M on this line. Now, because this is passing through 1 minus 2, 3 and it is parallel to the line this. So, the equation of the line PQ will be x minus 1 by 1 y plus 2 by 4 equal to z minus 3 by 5. This is the line PQ equation. If I am writing any point on this, let it be M. So, this will be again equating it to r plus 1, 4r minus 2, 5r plus 3. This point M is lying on the plane. Substituting in that 2r plus 2, substitute in this plane this point, plus 12r minus 6 minus 20r minus 12 plus 22 equal to 0. Minus 6r, 14 minus 20r, 2 minus 6 minus 4 minus 16 plus 6 equal to 0. So, r equal to 1. So, we get the point M to be equal to 2, 4 minus 2, 2, 5 plus 3, 8. This is this point, we want the distance PQ, and you know that for if this is the image, Q is the image of P, this will be the midpoint and this is double the distance. So, if you find out PM distance, twice will be the distance PQ. So, PQ equal to 2 PM, which is equal to 2 root of P point is 1 minus 2, 3 and M point is 2, 2, 8. So, 2 minus 1 whole square 1 square, 2 plus 2 4 square, 8 minus 3 5 square. So, this is root 2 root 42 is the image distance PQ. 25, 16 and 1. Okay. So, this is image of a point with respect to a plane. Now, if it is image of the line with respect to a plane, if you are given the line and if you want to find the image of the line with respect to the plane. This problem has been asked several times. So, this is your plane, you are having a line here, you want the image of this line with respect to this plane. So, if you can find out any point on this line, it is enough, you can write the equation of this line. So, to find that, what we do here, the image of the line is x minus 1 by 3 equal to y minus 3 by 1 equal to z minus 4 by minus 5. And the plane is 2x minus y plus z plus 3 equal to 0. This is the equation of the plane 2x minus y plus z plus 3 is 0. These ABC are the drs of the normal to the plane. So, the drs of this line will be 2 minus 1, 1. Let this point B be some x, y, z. We have a point on this line which is 1, 3, 4. So, how we proceed with this problem? First we take any point M on the plane. Now let us first write equation of AB with drs, proportional drs we have here. So equation of the line AB will be x minus 1 by 2 equal to y minus 3 by minus 1 equal to z minus 4 by 1. Now write any point on this AB to get this M. This is 2r plus 1 minus r plus 3 r plus 4. I am writing x, so first let me write B point. X I am writing here, x is 2r plus 1 minus r plus 3 and r plus 4. To get M we will use the midpoint formula. M is midpoint of AB. A point is 1, 3, 4. So I want midpoint of AB which is x1 plus x2 by 2, y1 plus y2 by 2 and z1 plus z2 by 2. This M lies on the plane. Substituting 2 into 2r plus 2 by 2 minus of minus r plus 6 by 2 plus r plus 8 by 2 by plus 3 equal to 0. Let us keep the 2 as it is. 4r plus 4 plus r minus 6 plus r plus 8, multiply this 2 here, plus 6 is 0. So we have 6r, 14, 18 minus 6 plus 12 is 0. R is minus 2. Substituting we get the point B here, x, y, z. I want the B point. Now when we get the B point, it is minus 4 plus 1, so minus 3, 2 plus 3, 5, minus 2 plus 4, 2. We have got the point and drs of this line will be the drs of this line also because it is parallel. So we have x minus 3 by 3 equal to y minus 5 by 1 equal to z minus 2 by minus 5. This is the equation of the image line with respect to the plane. The shortest distance you have the formula, so you can use the formula and do this problem. So in many of the problems in these lines we have used equal to r. This is important. Whenever you want to write a point in a plane, taking that on a line equal to r will solve many of your problems. I hope you will try many more problems and practice this, and I wish you all the best for your JEE Mains exam. Thank you.